Okay, let's go through this test on differentiation there. So the first question, differentiate the function x squared minus 2x from first principles with respect to x. So from first principles, we know that dy over dx is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So that's the method of first principle. So f of x is what we need to differentiate. So f of x is this part up here. It's x squared minus 2x. X squared minus 2x. And then f of x plus h just means anywhere there's an x here, we fill in x plus h. So instead of x squared, it's going to be x plus h squared. So x plus h all to be squared. And instead of minus 2x, it'll be minus twice x plus h. And then we take these two things and fill them in here and work out this limit. And that's what the question is asking us to do. So let's simplify this down a little bit first. So x plus h squared means x plus h times x plus h. So it's going to be x squared plus 2xh plus h squared, and then minus 2x, and then minus 2h. So minus 2h. Can we add up anything there? So we've got x squared minus 2x, 2xh, 2h. No, we can't. Okay, so dy over dx then is the limit as h approaches 0 of f of x plus h, which is this. So it's x squared plus 2xh plus h squared minus 2x minus 2h minus f of x. So just be careful here. It's minus, just put a line there, just it's minus all of f of x. So it's minus this part and minus this part here. So I'm going to put it in brackets. So it's minus f of x, which is x squared minus 2x, and then it's all divided by h. So when I simplify that now, I get the limit as h approaches 0. I have x squared minus x squared. So the x squareds are gone. I have 2xh. So 2xh. I've got plus h squared. I've got minus 2x. So you see that minus 2x there? And then it's minus 2x. So that'll become a plus 2x. So that's gone. And then I have minus 2h all divided by h. I can divide by h now. So when I divide by h goes into 2xh, h goes into h squared, and h goes into minus 2h. So I get the limit as h approaches 0. H into 2xh goes 2x times. H into h squared is plus h, and h into minus 2h is minus 2. And now I can work out the limit. So I end up with dy over dx, which I wanted to find, is equal to work out this limit, I just fill in 0 for h. So I get 2x plus 0 minus 2, which is equal to 2x minus 2. Okay, so the second question then. We're given if y is equal to x multiplied by e to the power of x, we have to find dy over dx. So the first thing you notice is that this is a product. So we're going to use the product rule. And the product rule says if f of x is equal to u of x times, let's say, v of x, then f dash x is equal to u of x times v dash x plus v of x times u dash x. So if you don't understand that, if you go back to the video on the product rule. So we have a product here. We've got x multiplied by e to the power of x. So the first part, we've got u of x is equal to x. So u of x is equal to x. And v of x is the other part of the product. It's e to the power of x. And now if you look at the product rule, I have to find u dash x and v dash x. So u dash x will just mean to differentiate this. So when I differentiate x, I get 1. And v dash x, well, when I differentiate e to the power of x, I also get e to the power of x. So then by the product rule, f dash x will equal, just fill it into what I have over here. So it's u of x times v dash x plus v of x times u dash x. So it'll be x times v dash x, so times e to the power of x, plus v of x, so times e to the power of x times u dash x, which is 1. So that's the answer here. It's x e to the x plus e to the x by 1. I can tidy that up a little bit. I'm going to factorize out e to the power of x. So I get e to the power of x by, so e to the power of x by x, and then e to the power of x by 1. So if I multiply that out, you'll see I get back to what I have up here. So that's the second question. Let's have a look at the third one then. So we have question, it's kind of using what we got in the previous question, because it says find the equation of the tangent to the curve. And if you look at this curve, that's the same curve we had in the previous question, x e to the power of x at the point 1e. Okay, so first part of it, we're looking for the equation of a tangent. A tangent is just a straight line, so this question really is asking us to find the equation of a line. So the equation of a line is y minus y1 is equal to m by x minus x1, where x1 and y1 are just a point on the line. So you can see here, there's a point on the line. So we have 1e. E, remember, is just a number. It's an irrational number, 2.718, but it goes on forever. It's an irrational number. So don't leave it as e. Don't fill in the decimal value of e, because it's an irrational number, so you won't be able to fill it in anyway. So x1 is 1, y1 is e, and m is just the slope. And if you remember, the slope the slope of the tangent is the same as the slope of the curve. So in order to find the slope of the tangent, I just find the slope of the curve at this point here. So the curve is y is equal to x e to the power of x. So we have y is equal to x e to the power of x. Now I know from the previous question, dy over dx, the slope of the curve is equal to e to the power of x by x plus 1. That's what we did in the previous question. So dy over dx, the slope, dy over dx when x is equal to, well, we want to find the slope at this point here. So we want to find the slope when x is equal to 1. So when x is equal to 1 would be equal to, just fill in 1 into the slope. So I get e to the power of 1 by 1 plus 1. E to the power of 1 is just e. So I get e multiplied by 2, or just twice e. So that's the slope of the line. So just leave it as twice e. Don't change it to twice 2.718 or anything like that. It's just twice e. So now let's fill it into everything up here, into the equation of a line, because that's what the question was asking us to do. So we have to get y minus, so we have x1 and y1. x1 is 1, y1 is e. So y minus e is equal to m, which is the slope, which is 2e. So 2e times x minus 1. So now I just simplify that out. I can multiply it out. So I get y minus e is equal to 2e times x is just 2ex. And then 2e times minus 1 is minus 2e. I could bring all the e's together. So I have y is equal to 2ex minus 2e plus e. So I end up at the end with y is equal to 2ex. And then minus 2e plus e is just minus e. And that's the answer. It's the equation of the tangent to the curve at the point 1e. Okay, next question then. So we're given the area of a healing wound. So we have a wound, a cut, and the area of that cut, or the healing wound, the wound, is given by a is equal to pi r squared. And you'll notice that pi r squared is the area of a circle. So it's like you have a cut on your hand or whatever, on your finger, and it's in the shape of a circle, and the area is given by this. That's all the first sentence is saying. Where order is the radius length of the wound. If the radius is decreasing at a rate of 0.5 millimeters per day, so the radius is decreasing at this rate, we write that in mathematical language as dr over dt. The rate of change of radius with respect to time is equal to, and it's 0.5 millimeters per day. But because it's decreasing, we say it's a minus. So the radius is decreasing at a rate of 0.5 millimeters per day, or dr over dt is equal to 0.5, and then I can put in the unit, it's millimeters per day. Okay, so that's just that sentence, this sentence translated into maths. The question says, find the rate of change of area of the wound when the radius is 10. So we can leave this bit till the very end. Leave that till the very end, we'll come back to it. What the question is asking us to do is to find the rate of change of area of the wound. So we know the area of the wound is a is equal to pi r squared. So a is equal to pi r squared. We want to find the rate of change of area of the wound. So that means we want to find dA over dt. The rate of change of area with respect to time. That's what the question is asking us to find. So, okay. We know that dr over dt is equal to minus 0.5. We know that a is equal to pi r squared. That means we can differentiate this with respect to or, so we can find dA over dr is equal to, well, pi is just a constant, so to differentiate pi r squared, it's just going to be 2 times pi times r to the power of 2 minus 1. It's just the same. We're using the x to the power of n rule. If you remember, x to the power of n differentiates to give us n x to the power of n minus 1. So we go 2 times pi, so 2 times the constant, is equal, or to the power of 2 minus 1. So that's 2 pi or. So the rate of change of area with dA over dr is equal to 2 pi or. So we know dr over dt is minus 0.5. We know dA over dr is 2 pi or, and we want to find out what dA over dt is. So we need to set up an equation to get dA over dt. And the equation will just look like this. dA over dt is equal to, and okay, we'll have dA over something multiplied by, we're using the chain rule here, so multiplied by something over dt. So we know dr over dt, we know dA over dr, so dA over dr times dr over dt. If I multiply out these two things, the drs they'll go, and I'll be left with dA over dt, which is what I'm looking for. So dA over dt is equal to dA over dr, which is, where are we? It's 2 pi r. So it's 2 pi r multiplied by dr over dt, which is minus 0.5, so minus 0.5. And now I can go back up to the bit at the end here. This is dA over dt, but we want the rate of change of area. We want dA over dt when the radius is 10. So now I fill in 10 into this. So when the radius, let's move this up. So when the radius, so when r is equal to 10, dA over dt is equal to, fill in 10 into this, so it'll be 2 pi by 10 by minus 0.5. So I end up with, well, 10 by 2 pi is 20 pi, and 20 pi by 0.5 or minus 0.5 will give me minus 10 pi. And don't forget to put in the units. So it's the rate of change of area with respect to time. So the units for this would be, well, area is measured in, what are we given? Is it in centimeters? Well, everything is in millimeters. Rate of change of area, we're given pi r squared. Yeah, it's in millimeters. So the area is going to be, the unit would be millimeters squared, which is the unit for area, per day. I think that time is given in day, is it? Yeah, 5 millimeters per day. Okay, let's have a look at the next one then. So, question is just saying, find the derivative of the function f of x is equal to the square root of x with respect to x. So if you remember with the square root, there is no way to, there's no rule for differentiating in square root, but we know that a square root, if f of x is the square root of x, another way to write that, instead of writing the square root of x, I can write x to the power of a half. Square root, just another way, it's just another way to write the square root. And this is easy to differentiate because now I can use the x to the power of n rule. X to the power of n differentiates to give us nx to the power of n minus 1. So x to the power of a half, if f of x is equal to x to the power of a half, then f dash x, the derivative of this, will equal, we'll just follow this, instead of n I have a half, so it's going to be a half x to the power of a half minus 1. So I can tidy that up, I get a half x to the power of minus a half. And that's the answer. We can tidy it up a little bit by realizing, well, anything to the power of a negative number is 1 over that thing to the power of the positive number. So that's the same as 1 over 2, and instead of x to the power of minus a half, I can write 1 over x to the power of a half. And then, well, x to the power of a half is the square root of x, so I can rewrite that as 1 over 2 by 1 over the square root of x, and then I can just multiply them just to tidy it up fully. Top by top, they're two fractions, so 1 by 1 gives 1 over 2 by the square root of x is 2 root x. Okay, last question then. We have to differentiate x squared plus 3x to the power of 5. So this is going to be the chain rule here. So we've got two functions. We've got a function here, x squared plus 3x, and then we've got all of that to the power of 5, which is the second function. So by the chain rule, we're going to write down our two functions. So we have g of x is equal to x squared plus 3x, and let's say h of x is equal to, well, h of x is all of this to the power of 5. So it's g of x to the power of 5. So g of x to the power of 5. And now on both of these things, I can use the x to the power of n rule to differentiate. So again, x to the power of n differentiates to give us nx to the power of n minus 1. So to differentiate g of x, I get g dash x. Differentiate x squared using this, I just get 2x. And differentiate 3x, I get plus 3. I've got h dash x over here. Well, this, I've got something to the power of 5, so something to the power of n. N in this case is 5. So I'll get 5 multiplied by g of x to the power of 5 minus 1, which is 4. And now I just fill in what g of x is. So it's 5 times g of x is x squared plus 3x, all to the power of 4. So now, in order to find f dash x, dr dy over dx, so f dash x, so we were asked to differentiate this up here. So that's what I'm calling this function up here is f of x. We'll say that function there. So f dash x, this whole function differentiated, will be, all I have to do is multiply g dash x by h dash x. So g dash x by h dash x, and I get 2x plus 3, 2x plus 3 multiplied by 5 times x squared plus 3x to the power of 4. I just want to show you a few mistakes that people often make when they write that. What I've written isn't quite right. What I should do is I should put brackets around this, because we want to multiply g dash x, which is all of this, by all of this. So I put it in brackets to mean I multiply. The other mistake that people make is they think that they can tidy that up by going 2x plus 3 and then multiply 5 by what's inside the brackets, get 5x squared plus 15x all to the power of 4. That's not right. You can't do that. You can't multiply 5 by this before you get it to the power of 4. You have to get it to the power of 4 first, and then you can multiply by 5. So this line is incorrect. So just stop here. This is it. One other thing that we could do, actually, we could take this 5, because it doesn't matter the order you multiply things. We can't multiply by this yet, because I have to get it to the power of 4, but I could multiply 5 by the two things that are here. So I get 2x by 5, and I get 10x. Keep it in brackets, because I have to multiply that by this afterwards. And then 5 by 3 is plus